Now we go to the next step, the loop inside the loop, or the nested loop, where we use two registers to hold the count greater than the maximum count of 255. So as you refer back to the previous example 3.2 in your text, the maximum count can only be 255. So what happens if we want to repeat an action more times than 255? Well, we can essentially double that or multiply that out with each nested loop that we create inside a loop. To do that, we use a loop inside a loop, which is called the nested loop. In the nested loop, we use two registers to hold the count. So if we take a look at an example here, we're going to write a program that first loads to port B SFR register a value of 55 hex, and then B complement the port B 700 times. So we've got what seems like a pretty formidable task here, but let's take a look at it and understand how using the loop inside a loop or nested loops that we can create this task. So the solution then is, because 700 is larger than 255, the maximum capacity of any register, we use the two registers then to hold the count. The following code shows how to use a file register location 25 hex and 26 hex as a register for our counter. So you can see the first two lines here, we've named R1 and R2. We've equated them to the locations 25 and 26. So in this program then, the file register location 26 is used to keep the inner loop count. So we've got an outer loop count and an inner loop count occurring in this 700 times counter. In the instruction B and Z loop underscore 2, whenever location 26 then becomes 0, it falls through and we decrement F R1 F and execute it. Okay, so we've got a decrement F going on here that is going to, right there at the bottom, that is going to be our outer loop each time we max out the inner loop. This instruction forces the CPU to load the inner count with 70 if it's not 0, and the inner loop then will start again. This process will continue until location 25 becomes 0 and the outer loop is in fact finished. Okay, so you can see here those values: working register when it equals 0 at the inner loop value. Then we're going to load 70 into location 26H. So we've set everything up in the top here. We've put our values in at the working register and the port, and then we start doing our counting within both of the loops until we reach the point that we're at the end of the target. Okay, so file register location 26 then used to keep the inner loop count, and again in the instruction B and Z loop underscore 2 whenever location 26 becomes 0. So there's our B and Z loop 2, repeat when it becomes 70 times. Okay, so got a repeat in here. Okay, so just a few short lines. Again, the whole first part of this is setting up our parameters, and then the bottom lines are actually the action of the looping that goes on in this nested loop. Okay, and we can take a look at it in terms of the flowchart and follow through what is actually happening in our flow chart and comparing it with our codes. You can see we've got a test here and we've got a test here. In both cases, we're looking at the value of counter 2 and the value of counter 1. Once it is satisfied, it bails out and the program ends. So it's good to take a look at the flow charts and understand the logic to go in. If your program isn't working, your little sketch isn't working, try putting together a flow chart and see if it helps you to solve where you might have gone wrong in writing your code. So now in a next example, we're going to extend it where we did a 700. Now let's take a look at 100,000 times here, because 2 registers gives us a maximum value of 65,025, which is a product of 255 times 255, giving us 65,025. We can use 3 registers to get up to more than 16 million, or 2 to the 24th iterations. So let's take a look at what we can do with 3 registers to get 100,000 repeats in doing a nested loop. Okay, I don't have that here, but if you take a look in your text, you can see that on about page 104, there is a process there of using 3 registers, going through the same type of process where we count down between register 1, register 2, and register 3, and eventually having the process come to an end. So in the next section, we'll take a look at some other conditional jumps that allow us then to move in and out of a program or a nested loop, and it becomes a very modular technique to do programming.